Hello, everybody. So here is a hybrid example, just one more example of a hybrid circuit, so you have this to help you out. A 57-volt power source has a 5-ohm resistor that is in series with a parallel array. Now, these three parallel resistors, you have a 22-ohm resistor, a 15-ohm resistor, and a 9-ohm resistor. They're all in parallel with each other. So the first thing we're going to do, of course, is a redraw. So the redraw takes the parallel circuit, keeps it in line with that 5-ohm resistor, but it replaces all the resistors in the parallel array with a single effective resistor. Now, how are we going to do that? Well, we're going to use that principle by which we find out the resistance of them. Now, if you look in your reference table, the formula is 1 over Req. That's the reciprocal of the effective resistance, can be found by taking the reciprocal of the first resistor, added to the reciprocal of the second resistor, and so on and so forth. It is important to realize that when you get the answer for this, it's the reciprocal of the effective resistance, and you have to take the reciprocal one more time. But to make sure we understand what that resistance has to be, let's take a look at this. If we did not have a line open through these, we have a 9-ohm resistor. So by opening more lines, it's not possible that the resistance increases more than 9 ohms. So the resistance of this must be less than 9 ohms. Further, let's imagine if these were both 9-ohm resistors. Well, then there would be 3 paths, each with a 9-ohm resistance, giving you a total resistance in this of 3 ohms. So when we look at the logic, we can see that the resistance must be lower than 9 ohms and above 3 ohms. That'll keep us from making some silly mistakes here. So how do we do that? Let's take this and do reciprocals on it. We have 22 ohms, take the reciprocal, plus 15 ohms, take the reciprocal, plus 9 ohms, take the reciprocal, equals. Now, notice that that is 0.223. That is not between our 9 ohms and our 3 ohms that logically this would have to be, and that reminds us to take the reciprocal one more time. That gives us 4.48, 4.48 ohms, and that does satisfy the requirement of being less than 9 ohms and more than 3 ohms. All right, we have that in line with our 5-ohm resistor, and we need to do one more redraw. Now, this redraw will put all the resistors together in a single effective resistance, and this is using the principle of series circuits. And what will that be? Well, 5 ohms and 4.48. That, without even a calculator, you got 9.48 ohms, and we still have a 57-volt battery on it. 57-volt battery. So we know the entirety of that 57 volts is dropping across that. And now we can start working with Ohm's law. When you're going to work on these, it's a good idea to put down all the variations of Ohm's law. Now we know that resistance, by definition, is how much electrical pressure, that's voltage, it takes to push along a particular current. So R equals V over I. I then equals V over R, and V equals IR. So it's good to have all these at your disposal, and really nothing beats writing them down right on your paper so you can use them when needed. So right here, the first thing we need is to find the current. And we remember I equals V over R, or 57 volts divided by 9.48 amps, or 9.48 ohms, excuse me. And that is approximately 6.0 amps. Great. Well, now we know that current must be going through this, 6.0 amps, and it must be going through this, 6.0 amps. In this effective resistance, there's no other pathway. So all of that current must be going through these. Now we can find our voltage drop. V equals IR. So let's use the current that we have here. I'll store that in the first location, and so that current times 5 ohms gives me, look at that, 30 volts. Okay, recall 1 times 4.48. That gives me 27 6.9 volts. Now stop. Are we doing okay? The whole purpose of doing all of this is so you can check your work endlessly. I have approximately 27 volts and 30 volts. Does that equal the voltage that I have from the battery? It does. That is indication that I'm doing this pretty good. All right, so from this, what transfers up here? Well, first of all, this 5 ohm resistance is done. We know it's 6.0 amps, giving me 30 volts dropping across it. But what of these numbers transfers up here? Well, there's different resistances, and that'll control how the current is going to flow through here. So the current will split up. But the voltage drop between this point and this point, we know to be 26.9 volts. And 26.9 volts, 26.9 volts. And that's going to be the voltage drop across each of these resistors. So now, I equals V over R. All right, I'm going to store that in location 2 so that I can use the direct number there. So that's the voltage drop divided by my 22 ohms. That gives me 1.2 amps of current there. Recall that voltage. Divide it by my 15 ohms. That gives me approximately 1.8 amps there. And recall that voltage divided by my 9 ohms. And that gives me about 3.0 amps there. And how are we doing? Well, I have 6 amps running through the circuit. Does that split up evenly here? Well, 1.2 amps and 1.8, that's 3 amps, plus 3 amps, that's 6 amps. My voltage drop, 27 volts here, 30 volts here, gives me 57 volts there. So I have solved this. I feel very confident that that is the solution because all the numbers check out. This reminds you, you can make up your own hybrid example. You can make it as complex as you want. And if you just follow the logic, you can do anything you'd like. If you put in more elements, you may have to do some more redraws. That's all. But this is all pretty straightforward. If you could do a hybrid, that means you understand series, you understand parallel, you understand the basics of resistance insofar as it pertains to circuits. Hey, thanks for watching. Hope this helps.